This video is going to be outlining the body module of your space race project. The things that we're going to talk about in this module are the purposes of the rocket body, some reasons why it's made the way that it is, and maybe some of the things that you might need to keep in mind as you design your own. So, first things first, what is the purpose of the body? Okay. The first purpose of the rocket body is to protect anything that is housed within the rocket. Okay, in our case, that is going to be your payload compartment, and so that outside of the body needs to be able to be sturdy enough to keep the inside of your rocket safe. The second purpose of the rocket body is to direct airflow in a way that it reduces drag. Okay, and again, drag is air resistance. Is when we talked about our friction unit. Okay, it's friction caused by air. All right. So again, what is drag? Drag is friction caused by air. Okay, so it is any time that something is going to oppose the normal motion of an object. Right. In this case, instead of using the ground causing friction, it will be the air particles causing friction. So how do we reduce drag? Okay. If we go back to our lesson on friction, the thing that caused greatest friction was a large surface area. Okay, so again, this is still going to apply for your rocket. The larger your surface area, the more drag you're going to have. And drag, in the case of rockets, is bad. It keeps you from going your maximum height. Okay, so here I have two shapes. I have a cone and I have a cylinder. All right, the cone and cylinder both have the same circle size at the base, okay? But the cone comes to a point, whereas the cylinder has the same area on top as it does on the bottom. So if we went through and we calculated the surface area, obviously the cylinder is going to have a much greater surface area, and therefore it would experience more drag. That is why most rockets are tipped with a cone shape. You will never see a rocket that has just a flat top like a cylinder. Another thing that your rocket's body is going to do is stabilizing. So again, drag is not necessarily always bad, okay? Drag is also going to help us keep a stable flight pattern for your rocket, okay? And the way we do that is you put fins on it, right? So again, it's going to be using that drag element to direct airflow in a way that keeps the rocket pointing in the right direction. You may want to include several fins on your rocket to make sure that it continues to fly upward and then not tilt over in the middle of flight and shoot horizontally. So as you calculate drag, you're going to be using the same friction equation that we have been using for this entire unit. Okay, you're still going to be using friction equals mu, which is your friction coefficient, times n. The only difference, however, is that you guys are going to need to find the air friction coefficient for your air conditions when we launch this rocket. Now, since we're looking several weeks into the future, you're not going to be able to know exactly what the air temperature is going to be. So for this module, what I'm having you do is figure out what the air friction coefficient for 75 degrees Fahrenheit or 25 degrees Celsius would be. Okay. So for the materials for this portion of your rocket, okay, you might want to include some materials like a plastic bottle or a paper towel roll or PVC pipe. Okay, each one of those materials for your body are going to offer different strengths and drawbacks that the other ones might have or be missing. Okay, for example, a plastic bottle or a paper towel roll is pretty light. Okay, so the overall weight of your rocket is going to be less, therefore it'll be easier to get it off the ground. However, the drawback is both of those things are pretty flimsy, whereas a PVC pipe is going to offer more internal protection for the fragile components of your rocket. So with some of those things in mind, let's move on to the requirements for your project. Okay, so for this module, you're going to need to create a digital design for your body of your rocket. Okay, so for this thing, I'm going to need you to include a materials list, assembly steps, dimensions. Okay, you need to include all of those things, all the things that somebody who would be wanting to recreate your rocket would need in order to successfully build it. The second thing you're going to need to do is draw a free body diagram that's going to be showing all the forces that would be acting on the body of your rocket. Okay, to give you a hint, one of the major ones is going to be drag, And then obviously there's some other forces at play that you're going to need to include that would be working on the body of your rocket. Okay. And then finally, I need you to use, again, that air friction coefficient to calculate the drag force on your rocket. Okay. And again, you'll be using that friction equals the normal force times the friction coefficient in order to figure that out. So, with the groundwork laid, you guys should be ready to go and complete this module. So, good luck building, and we will be in touch.